In this video, we're going to talk about volume, and specifically of prisms and cylinders. So volume is the measure of the amount of space needed to fill a solid. So if you were to fill this up, how much stuff is here? So if we look at this shape here, we've got a bunch of blocks. We have 4 blocks in this direction, 2 blocks in this direction, and 3 blocks in this direction. Okay, and if we count the number of cubes, there ends up being 24 cubes, which is 3 times 4 times 2. So for a rectangular prism, we'll just do length times width times height. If the base is something different, the volume is b times h. So b is the same variable that we've already dealt with, where b is the area of the base, which could be many different things. It could be a square, it could be a trapezoid, it could be a pentagon, it could be a triangle. Okay. The h is height, but I prefer to refer to this as the distance between the bases. Okay, so let's look at some examples. Okay, this first one is just a rectangular prism. So we're just going to multiply 4 times 7 times 5 in no particular order and get 140 centimeters cubed. This next one, my base or bases are these triangulars. We'd call this a triangular prism. Okay, so the volume is going to be the base times the height. Okay, the base is a triangle, so it's going to be 1/2 base times height. I'm going to do this over here because this base and height are different than this base and height. This is specific to the triangle. We have the height of the triangle is 5. The base of the triangle we don't have. We're going to use the Pythagorean Theorem. So 5 squared plus b squared equals 13 squared. When you solve this, you will get 12. So the area of our triangle is going to be 1/2 12 times 5, which gives us 30. That we can plug into here. So the area of the base is 30. The height, or the distance between the two bases, is this 3, and that's why I want to refer to it as the distance between, so it's 90 meters cubed, as the distance between the bases, because when you look at this, if I ask for height, you might want to say 5, but the height of the prism is the distance between the two bases, which in this case is 3. If I sat the shape on the triangle, we'd get 3. Okay, so we'll try these next two. For this one, the base is a trapezoid, which is going to be the height times the sum of the bases divided by 2. The height of the trapezoid, so we're just looking at this shape here, is going to be 1.5. The two bases are 3 and 5. So when we calculate this, we will get 6. So volume is base times height. Base is 6. Height is 3.5. So we get a volume of 21. This one, the height is the perpendicular distance between the bases. So this is just going to be our base here is going to be this shape. So that's going to be 10 times 15. And our volume is going to be the base times the height, which gives us 1,800 feet squared. Next we have our cylinder. The base of the cylinder is a circle, so it's essentially going to be the same formula where we have the area of the circle and then we'll multiply that times the height to get the volume. So our volume is pi r squared h. R is the radius of the base, and our h is the height, which is a little bit more obvious on the cylinders. All right, so let's work some examples of this. So my volume is going to be pi r, which is 4, squared, times the height, which is 11. And then we just dump that in a calculator to get 552.9. Units here will be centimeters cubed. This one, we have one small calculation. This is the diameter. So my radius is going to be half of that, or 10. So this one ends up having a volume of 6,283.2 feet cubed. Okay, so I'd like you to pause and try the final two, and we will check your answer momentarily. All right, time to check your answers. Here, our radius is 2, height is 1, so we get 12.6. Here, my radius is 13. When they draw it all the way across, we're referring to the diameter. So radius of 13, height of 28 gives me 14,866. So that is the volume of pyramids and cylinders.